Okay, so again, let's look at the steps. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. Is that true for this? Yes, then I'm going to sketch this. Okay? Y equals 0. No vertical asymptote because the denominator has no real solutions. That's true. X squared equals negative 2. I can't do that. No vertical asymptote, so it's going to be one of these funky kind of graphs. All right? Then you would go to, first, let's just not even go to the calculator. Let's just figure out what the y-intercept is. If I plug in 0 for x, what's y going to be? 2. So I want you to show me that right there. Okay? Then you can go to your calculator, get some other points. But always show me the intercept. So it would be 1 4/3, negative 1 4/3, 2 2/3, and then they're always reflections of each other when you have this kind of graph. So over 1 up 4/3 is about here and here. Over 2 up 2/3 is about here and here. You're going to have reflections. Okay? And they go forever. Let's do the domain. What could x be in this graph? Anything. Let's look at the range. It's going to be between here and here, isn't it? And it's going to include that. So the range is going to be greater than 0, but less than or equal to what? 2. And if this is funky for you to write, you can split this up. You can write it as this if you want. I don't care. You could say y has to be greater than 0, but also y has to be less than or equal to 2. It doesn't matter. If you can't figure out how to do it like this, then do it like this. Got it? Okay. All right, turn it over. That's the first form. We got 2 others to look at. Okay. Graph the function, state the domain and range and asymptotes. Number 1. If the degree of the numerator is equal to the degree of the denominator, like right here, then y is the number in the numerator divided by the number in the denominator, just like we saw yesterday. So this is negative 1 here and 1. Okay, so step 1. I look at it like this. Y is equal to negative 1 divided by 1, which is negative 1. Okay? So I'm going to sketch that asymptote. You're going to have 3, sometimes 4 asymptotes in these equations, because there's all sorts of restrictions. Okay, number 2. The denominator has 2 real solutions. Those are the vertical asymptotes. When you have this situation, degree here are equal, this is going to happen. So you do x squared minus 4 equals 0, and you got to solve for x from the denominator. X squared equals 4. What is x going to equal? Plus or minus 2. Okay? So now I have those 2 asymptotes as well. So I'm going to sketch those. Here's x is negative 2. Here's x is positive 2. Okay? Then I have a number 3. Solutions to the numerator will be the x-intercept. So that means I have to set that equal to 0, the numerator, and see what the solution would be. What would the solution be? Can you see it? Divide by negative 1, x squared equals 0. X is just going to be what? X is 0. Okay, so I'm going to plot that point. So then, now it's like, I can show you what it looks like, but now let's go to the graph. I want you to do it on your calculator so you know which way to draw the branches and you know all this kind of stuff. They're cool. They're kind of fun looking, actually. All right, y equals, clear this out. I always use parentheses when I have division of fractions with variables. So negative x squared divided by parenthesis x squared minus 4, and close it. Can you see it? Yeah, it's really cool, isn't it? Look at that. 3 branches. 3 branches. This is why I went to talk to him this morning. I'm like, yeah, but Barrett, if this is negative, wouldn't it make it go down? He goes, look, it gets way complicated. Just have him point out all this stuff, go to the calculator and sketch it. Deal? Talk about it in pre-calc. So sketch it. Don't go over your asymptotes. And state the domain and range. So let's think about that. Okay, domain. Nah, not for this. Now, let's look at this. X can be anything because I have these 3 branches except for what 2 numbers? Right. So it could be any reals, but it can't be plus or minus 2. Now, Y gets a little funkier. The range. Okay. The range can be pretty much anything except for this area right here. That is where it cannot be. However, can it be 0? Yes. So we're going to write that out. We're going to say, okay, then it looks like this. The range could be anything except where Y is greater than -1, or Y is less than or equal to 0. So that's the place that it can't be. Here. Do you get that? Doable? Okay, let's do one more. So first of all, number 1. Let's do number 1. Number 1 is the Y asymptote. Horizontal. Y equals 3. You get that? 3 divided by 1. So sketch that on here. There's 1 asymptote. Number 2. Denominator has 2 real solutions. So I'm going to set the denominator equal to 0. Solve for that. X is going to equal to plus or minus 1. Sketch those vertical asymptotes right here. Okay, and then number 3. And this all occurs when the degree in the numerator is the same as the degree in the denominator. Okay, so number 3, the solution to the numerator will be the x-intercept. So set that equal to 0. And divide each side by 3. X is just going to be 0. So I do have an x-intercept of 0. You've met all those requirements. Go to your calculator. See what the funky graph looks like. Okay? It's good to get a couple specific points if you can. That's what it looks like. Okay, let's talk about the domain and the range. Domain. What can the x be? Anything in these 3 branches except for what? Reals, except it cannot be 1 or -1. Then the range. I'm going to color in where it can't be. It can't be here. Y will never be there. So you would say reals, but then you would say except where Y is greater than or equal to 0, because it could be 0 here, or Y is less than 3. So it can be anywhere else but those places. Does that make sense? You could write that differently too, but we'll just go with that. All right. Number 1. So here we have a slightly different situation. When the degree of the numerator is greater than the degree of the denominator, you're going to follow these steps. Okay? There is no horizontal asymptote. Got nothing here. So number 1, there's no y equals. No y equals. Did I write it wrong?
Yeah, I think you flipped the range. Shouldn't it be y is less than or equal to?
Well, I wrote, it could be all reals except where this happens.
Oh, okay.
So you could, like I said, you could write it differently. You could say all reals.
Except for that.
Yeah, however, yeah, you know what I'm trying to say?
Or you could just say
Where y is less than,
or equal to.
yeah, you could say that. Okay? All right, no y equals. Number 2, the solution to the denominator is the vertical asymptote. So let's find the solution to the denominator. X equals -2. These are really funky graphs. -2. And sketch that. There's only one vertical asymptote here. Number 3, the factors of the numerator. Oh, there's your fun word, factors. You have to find the factors. The factors of the numerator are the x-intercepts. So I got to factor the numerator. Okay, so the factors, x minus 1, so x equals 1. That is my x-intercept, so I'm going to put a dot right there. Now, you guys, this is a rational function. It's going to be a hyperbola, okay? You know there's a second part because it's a hyperbola. Just like we looked yesterday. When there's an x in the denominator, it's a hyperbola. When we graph it, we're not going to see the second branch. We have to look for that second branch and make sure you graph it. You just have to realize that. Okay, so go ahead and put this on your calculator and see what it looks like. This is really funky. I'm just saying. Parentheses in the numerator, parentheses in the denominator. Okay, so it's kind of a twisted sort of parabola, but we're only seeing one branch. Let's sketch that. It kind of goes like this. Now we got to look for the other part. It's going to be like a hyperbola because the x is in the denominator. So we're gonna make our window go down. I don't know. Let's go to -20. Y min of -20. Can you see that? Y min of -20. And then let's see if we can see the second branch. There it is. Somehow I knew this was -512. I might have traced somehow. Oh, I know what I did. This is what I did. I went to the table. Oh, look, -5, -12. And then I kind of looked, and it goes down from there. So that's the one point that I used to help me graph. 1, 2, 3, 4, 5, all the way down to about here. So I went to the table to help me draw that second branch, kind of see where it was situated. What? It's kind of down there. Well, because look, this is the highest point if I look at the y values, right? Comes up, and then it starts going down again. Can you see that? You understand that? There's nothing that's higher than -12 on that particular part there. Higher. So I know that that's, I mean, I didn't sketch it quite right. Do you know what I mean? So it kind of goes like that. All right, let's just do the domain and range, and then we'll be done. We won't do the next one. What can x be here? All reals except for what? And then the range can be all reals except where -12 and 0. This is -12. Okay. So if you want to say except where y is greater than negative 12 or y is less than 0 is what I should say. I kind of did do this one wrong. Except where that occurs. Can't be there. All right, so basically follow your steps. Check to see the degrees and figure out which method you're using. Yeah? Okay, you have a worksheet. You do it all except number 10.